Today we're going to go from number 51 all the way through number 75. So number 51 says, two parallel lines are graphed on a coordinate plane. Line K contains the points 3, -2, and 5, -6. And line J contains the points 4, -2, and 6, -6. So we can remember when we talk about quadrants, our quadrants are 1, 2, 3, and 4. Everything in quadrant 1 is positive, positive. Everything in quadrant 2 is negative, positive. Everything in quadrant 3 is negative, negative. And everything in quadrant 4 is positive, negative. So if we look at our ordered pairs, we know that all our ordered pairs are going to be in quadrant 4 and because they're all positive, negative. So if I graph this in quadrant 4, so I just drew the fourth quadrant, and we're going to have two parallel lines, and they're going to look something like this right here. So the first question says, if I rotate this 180 degrees clockwise about the origin. So if I go 90 degrees clockwise, I'm going to wind up in the third quadrant, and if I go another 180, I'm going to wind up in the second quadrant. So my first answer is second quadrant. And the two parallel lines stay parallel because they both get translated the same way. So your answer for that is yes. Second, it says if I reflect this over the x-axis. So this is the x-axis right here. So if I take these and I reflect them across the x-axis, we would wind up in this quadrant, which is quadrant 1. And again, just like in the other one, they stay parallel. If I reflect across the y-axis, I would go from here to here, which is the third quadrant. And so you would mark that as your answer. And once again, the parallel lines stay the same. If I translate this 7 units up, so I'm going to take both of these lines and I'm going to go up with them. And if I do that, I'm going to be in the first quadrant. And once again, they're still parallel. And if I translate 8 units to the right, which means I'm going to go in this direction, I'm going to stay in the fourth quadrant, but my lines are still going to remain parallel. So basically the moral of the story is, if you start with parallel lines, and it doesn't matter what kind of transformations you do, you're going to end with parallel lines. So let's look at number 52. It says a triangle GHI is plotted in the coordinate plane. The measure of angle G is 55 degrees, angle H is 60, and angle I is 65. If triangle GHI is reflected across the y-axis and rotated 180 degrees counterclockwise, to form G prime, H prime, I prime, what will be the measure of angle H prime? And we've said 100 times, whatever you do, your angle measure is not going to change. Whatever kind of transformation that happens, your angles will stay the same, even if you dilate. So, therefore, since the measure of H is 60 degrees, the measure of H prime is also going to be 60 degrees. And then number 53 says line segment OP has a length of 2 units and it's been plotted in the coordinate plane. If line segment OP is rotated 90 degrees and translated 3 units to the right, what is the measure of the length of O prime P prime? Well, the only transformation that changes the length of a side is a what? A dilation. That's the only thing that will change the length of a side. So, since we didn't have a dilation, we're going to have the length is going to stay the same, and it's going to be 2 units. Triangle ABC is reflected across the y-axis, rotated 30 degrees around the origin, and translated 7 units to the left, resulting in A prime, B prime, C prime. So the perimeter of triangle A prime, B prime, C prime will be equal to the perimeter of the first triangle, ABC, because size only changes with dilation, and we didn't have a dilation. The measure of angle CAB will now be equal to the measure of angle C prime, A prime, B prime, because just like before, your angles never change, no matter what we do to it. Number 55, triangle TRI is translated 3 units down and 11 units to the left. And so it says, what is the relationship between the length of side RI and the length of the corresponding side R prime, I prime? They're going to be equal because we didn't have any kind of a dilation, so they're going to be exactly the same. So the answer is B. 56. A line segment WX has a length of 8 units and has been plotted on the coordinate plane. If it's translated 2 units down and 3 units to the left, W prime X prime is going to be exactly the same as what we started with because there was no dilation. So your answer is 8 units. 57, line GH is translated 3 units up and 2 units to the left to form G prime H prime. So it says, what is the length of G prime H prime to the nearest whole number? So this actually involves Pythagorean theorem, which we're not going to learn until next week. But if I give you a problem like this, I would give you the length of this side right here. I would say to you, okay, this is going to be 7. And then I would expect you to know that if there is no dilation, the transformation length would be exactly the same. So if GH is 7, G prime H prime is also going to be 7 units. 58, a line segment CD, which is right here, has been graphed on the coordinate plane, and it says if it's reflected across the x-axis, what are the coordinates of the reflected segment? And so anything in this quadrant is going to be positive, negative, and the only ordered pairs that are positive, negative are C, which are 5, negative 5, and 3, negative 2. 59, this is kind of the same, along the same lines as the last one. It says, which other line segment is not a transformation of KL? If you notice, if you look at KL, the distance goes across 4 blocks. 1, 2, 3, 4. If you look at PO, the distance only goes across 3 blocks. So this one is too short, so your answer is C. Number 60, line segment PQ is translated 4 units to the left and 2 units down. And once again, this is another one of those that involves Pythagorean theorem, but I would give you the length of the diagonal. In this case, it's 5. So since we have no dilation, P prime Q prime would also be 5 units long. 61, line segment AB has been graphed and it is reflected across the y-axis. What are the coordinates of the new one? So we start here in the 3rd quadrant. If we reflect across y, it's going to be in the 4th quadrant, which means all your ordered pairs are going to be positive, negative, and so therefore your answer is B. 62, find AB on the coordinate plane. So that's this one right here. And if you notice, the length of this is across 3 blocks, and the one that's different is DC or CD because it only goes across 2 blocks. So it's too short, so your answer is A. 63, it says given triangle XYZ is located on the coordinate plane and angle Y measures 54 degrees. If you reflect across the Y-axis, the measure of angle Y is going to stay exactly the same because your angles don't change. And the same thing for number 64. If the measure of angle A is 78 degrees, the measure of angle A prime is going to be 78 degrees, no matter what you do to it. So it's going to stay exactly the same. 65, we have a rectangle, ABCD, and it says A prime, B prime, C prime is formed by translating this rectangle 2 units to the right and then reflecting it across the y-axis. So I'm going to move it this way and then reflect it all the way over here to the other side. So it says which statements below would be true in this situation. So it says AB is parallel to B prime D prime. By the way, the 2 lines up and down mean parallel, and the 2 lines with a line through them mean not parallel. So if I tell you that AB is parallel to BD, these 2 lines are perpendicular to each other, not parallel. CD is not parallel to A prime, B prime. So CD and AB are actually parallel to each other. And even if we translate them to the other side, they would still be parallel. So that's not true. And so then we get to C, and we say AC is not parallel to AB, which is true because they are perpendicular. So even if they were on the other side, that would still be true. So your answer is C. This is similar to the last one. So it says which statements would be true if you translate HIJK 3 units to the right and reflect it across the x-axis. And the one, statement B, is not true. It says JK, which is right here, is not parallel to HI. They are parallel. Let's look at the rest of them. IJ is parallel to IH. That is not true. JK is not parallel to HI. That is not true.
Teachers, if you would please excuse me for this interruption. If you have any students who have bank books checked out, if they would please go and return those to the library at this time.
Okay, this is true. So I think the answer should be C. 67 shall be drew two triangles on the coordinate plane as shown. So if you use patty paper to do this, and it says what series of transformations proves the two triangles congruent. So on your paper, you would draw the first one, which is TUV, and then you would go through all these different reflections. You would try reflecting it across the x-axis and then rotating it 90 degrees counterclockwise, and then rotating it 270 degrees clockwise, and then reflecting it across the y-axis, and then eventually when you get to C, which is reflecting QRS across the y-axis and then translating it 9 units up, that would give you the correct answer, and you would have TUV would lie directly on top of QRS. 68 is similar to the last one. You have to do the same thing. You need to use patty paper and trace one and figure out, you know, what would be the correct order or sequence of transformations that you need to use in order to get one to line up directly with the other. Your correct answer is C. 69, Noah drew a quadrilateral on a coordinate plane. It says determine which transformations listed below result in a congruent quadrilateral. So the symbol right here is the symbol for congruent. It's an equal sign with a squiggly line on top, and it means congruent. And if I'm going to remind you that congruent means same shape and same size. So if I reflect and then rotate, so if I do some kind of a reflection and then rotation, that means it's still going to be congruent to EFG because my size did not change and my shape did not change. The only thing that changed was where it was located. Anytime you have a dilation, it's not going to be congruent. Rotation followed by translation, yes, still congruent. And once again, on the last one, since we have a dilation, it's going to be not congruent. Anytime you have a dilation, your size is going to change, so it would no longer be congruent. Same thing here. Anytime you have a dilation, it's going to be not congruent, so there's a dilation here, and the rest of them do not have dilation, so they are all congruent. 71. We have parallelogram ABCD, and the transformation that would not result in a congruent trapezoid is a dilation by a scale factor of 2. So once again, if you have that dilation, your size is going to change. 72, quadrilateral JKLM. It says which of the following transformations performed on that quadrilateral would not result in congruence, and that is A, a dilation by a scale factor of 3/2. Anytime you have a dilation, it's not going to be congruent. 73, trapezoid PQRS is shown in the coordinate plane, and then it says which of the following transformations, if performed on PQRS, would not result in a congruent trapezoid, and the answer is C, because you have a dilation. And once again, a dilation causes you to have something that is a different size, whether smaller or larger. 74, it says what is going to be the new coordinate if I rotate this triangle 90 degrees clockwise. So we're going to start with finding the coordinate for L, which is right here. So I'm going to start at my origin. I go 1 to the left, and I go up 4. So my ordered pair is -1, 4. When I rotate something 90 degrees clockwise, I switch my x and my y, which changes it to 4, -1, and then I change the sign of the last coordinate, so it would go from -1 to +1. So my new ordered pair is C, which is 4, 1. 75, if I take a triangle and dilate it to a scale factor of 2 to create J prime, K prime, L prime, the two triangles will still have the same angle measures, but they will have different lengths of sides. So a dilation will change the lengths of the sides, but nothing will change the measure of an angle. Thank you, and we will finish up the study guide tomorrow.